Today I'm going to show you how to convert between polar and rectangular coordinates. The easier direction here is to go from polar to rectangular, so that's where we'll start. So first, let's convert the point 3, 3 pi over 2 from polar coordinates into rectangular coordinates. The 3 is a distance from the origin, and the 3 pi over 2 is an amount of rotation starting on the positive x-axis. For a lot of these, it's enough just to figure out where the point should be plotted, and that tells us what the x and the y should be. So we've rotated 3 pi over 2. So if we rotate 3 pi over 2, we're looking straight down. And if we walk out a distance of 3, we go 1, 2, 3, so our point is right there. Alright, well, clearly then, my x and y pair are going to be an x of 0 and a y of negative 3. So the point 3, 3 pi over 2 corresponds to the coordinates 0, negative 3 using rectangular coordinates. Alright, so if you happen to be one of the axes, you can just do it that way. Now what about 4, 5 pi over 6? Here, if you tried to plot it, you'd definitely get some idea where it is, but it wouldn't tell you necessarily what x and y are. Instead, let's use the fact that x is always equal to r times cosine theta, and y is equal to r times sine of theta. Alright, let's just plug in r, the 4, and the theta, 5 pi over 6, and we get that x is equal to 4 times 5 pi, not 5 pi over 6, cosine of 5 pi over 6, and y is equal to 4 times sine of 5 pi over 6. And cosine of 5 pi over 6 is root 3 over 2, so this is 4 times the square root of 3 over 2. And sine of 5 pi over 6, cosine would be negative root 3 over 2, being in the second quadrant. And sine of 5 pi over 6, it's positive, it is 4 times positive 1/2. Alright, so the point in polar coordinates 4, 5 pi over 6 corresponds to the point in rectangular coordinates. See, 4 times negative root 3 over 2, that is negative 2 square roots of 3. And the x-coordinate 4 times 1/2 is just 2. So there we have it. An x of negative 2 square root of 3, y is 2. So if you use these formulas, x is r cosine theta, y is r sine theta, it's easy to convert from polar coordinates to rectangular coordinates. Let's try to go the other direction now. So here I have two rectangular points, x is 3 and y is 2, and I want to convert it to polar coordinates. And I could try plotting this, but that's not going to tell me what the angle or the radius is. Instead, we'll use the fact that r squared is equal to x squared plus y squared, and tangent of theta is equal to y over x. Alright, so to figure out what r is, I just need to do r squared is equal to x squared, that's 9, plus y squared is 4, so that's 13, so r is equal to the square root of 13. And I have the first of my two coordinates for the polar coordinates, square root of 13. To figure out what theta is, I will say, well, tangent of theta is going to be 2/3. So theta should be tangent inverse of y over x, 2/3. And that's something I'd plug into my calculator, and I did that ahead of time. If I plug in tangent inverse of 2/3, I get approximately 33.7 degrees. This is an approximation. Alright, so my angle is 33.7 degrees. And I should check that I'm in the correct quadrants here. Well, the point 3,2 is definitely in the first quadrant, and my angle theta, 33.7, that's also in the first quadrant, so we're okay. We don't have to do any correction for that. So the point 3,2 goes to the polar coordinates, square root of 13, 33.7 degrees. Let's try another one. How about x is negative 1, y is square root of 3? Well, to figure out what r is, we would use r squared is equal to 1 plus 3. Negative 1 squared is 1. Square root of 3 squared is 3. So that's 4. So r is equal to square root of 4. That's 2. All right, so my polar coordinates are 2 comma something. And to figure out what theta is, again, I can use theta is equal to tangent inverse of the square root of 3 over 2. And again, square root of 3, over 2. Square root of 3 over the negative 1. Square root of 3 over negative 1. Now, this is actually a point I know on the unit circle, and this happens to be negative 60 degrees. That's what you'd get if you plugged into a calculator as well. Now, before we write down negative 60 degrees, we better make sure that we have the answer in the correct quadrant. Negative 1 comma square root of 3 is in the second quadrant, but negative 60 degrees is in the fourth quadrant. So this is not the right answer. Instead, what we want is we want to add 180 degrees to go halfway around the circle, and that'll give us the right answer. So that becomes 240. 180 minus 60 is 120 degrees. So our angle is 120 degrees. So the polar coordinates for negative 1 comma square root of 3 are an r of 2 and a theta of 120 degrees. All right, so I hope this has helped you figure out how to convert between rectangular and polar coordinates. Thanks for watching.